So an experimental study here. So in an experimental study, one variable is manipulated under controlled conditions to see if it has an effect on the other variable. So an experimental study is a study that can provide evidence for a cause and effect relationship. Okay? And the key here is one variable is manipulated, but you do it under controlled conditions, okay, to see if it has an effect on the other variable. So let's look at an example and see exactly what's going on with an experimental study. Okay? So let's take this same example of this researcher that's interested in whether or not a relationship exists between the number of hours someone works per week and their grade point average. Okay, so if this person did a correlation study, they would see the relationship. They would see a relationship exist, and it's a negative correlation. But if they wanted to prove that the relationship was a cause and effect relationship, then they would need to do something like this. They'd have to set up an experiment with controlled conditions. And the idea here is they're going to have two treatment groups. They're called treatment groups here. Okay? And what they're going to do here is they're going to, in this case, take 10 subjects, 10 college students, and they're going to randomly divide them between the two treatment groups. And then they're going to make all the students in one group work 10 hours per week. And all the students in the other group, they're going to make them work 40 hours per week. And now here's the key. They're going to try to keep all the conditions the same between the two groups. So anything that would affect the grade point average, maybe the classes that they're taking, the teachers that teach those classes, the amount of sleep they get, whatever might affect their grade point average. So they're going to do their best to keep them the same between the two groups. That's the control that they exercise. The controlled conditions is anything that affects the grade point average is going to be the same between the two groups, except for the number of hours that they work per week. And so here's the idea. At the end of the study, okay, they're going to collect the grade point averages of the two groups, and they're going to compare them, and they're going to see, is there a significant difference between their grade point averages? Okay? In other words, is the students that work 10 hours a week, is their grade point average significantly higher than those that work 40 hours per week? So just by looking at these, my own judgment, my own intuition, I would say these are significantly higher than these. Okay? And so I would say, yes, those that work less do have higher grade point averages than those that didn't. And the idea is if I kept anything, if I controlled any variable that would affect their grade point averages between the groups, I kept them the same between both groups, then the difference between the groups would have to be the one variable that I changed, the one variable that I manipulated, which is the number of hours that they work per week. Okay? So now, in an experimental study then, the independent variable is that variable that you manipulate, the hours that they work per week. It's the variable that you want to show as the cause. Okay? The dependent variable is the measurements at the end of the experiment that you're going to compare to see whether or not there's a significant difference between them. Okay? So they're the things that you want to show as the effect. So the independent variable you can think of as the cause, the dependent variable as the effect. Okay? And then there's one other type of variable, and they call it a confounding variable. And a confounding variable is any other variable that might affect the grade point average besides the independent variable. So this could be the classes that the students take, the teachers that teach those classes, anything that would affect their grade point average other than the number of hours that they work would be confounding variables. Okay? And the goal of the experiment, when you design an experiment here, the goal is you want to keep all the confounding variables to a minimum. Any confounding variable that you're able to control, you want to have that under your control, and you want to keep them the same between the two groups. This way, if there's a significant difference between, this should say dependent variable, my mistake here. If there is a significant difference between the dependent variables of the two groups, it can be blamed on that should be independent variable. Sorry. My mistake. That's too bad, but that's okay. So what it means is if there is a significant difference between the dependent variables down here, you can blame it on the independent variables. Okay? And so that's the idea of the experiment. And now, an experiment will never prove 100% that there's a cause and effect relationship. And the reason for that is you try to control the confounding variables, but you probably will never be able to control all the possible confounding variables. One reason is that you may not even know what some of the confounding variables are. There could be things that you don't even realize affect their grade point average. So even if you wanted to control them, you don't even know that they're there. Okay? Or there's other variables that you don't have any control over. There's some variables that you're not going to be able to control. And so you can never keep them to a minimum, but to whatever degree you're able to keep them to a minimum, you provide evidence for a cause and effect relationship. So what you're doing is the experiment provides evidence that there is a cause and effect relationship. It doesn't prove it 100%. Okay? One of the things that you also have to take into account is if there is a difference between these two groups, it could be just sampling error. Okay? In other words, maybe just when you randomly divided people between the groups, you got some smarter people in one group and some people that weren't quite as smart in the other group. And so they look higher here than here, but it's just a problem with your sample. It's sampling error. Okay? So you try to control that by, first of all, making sure people are randomly divided between the groups. Okay, so people have the same chance of being in either group as the other people. Okay, so it's randomly divided between the two groups, and the larger your samples. Okay, so if there were just two people, it could easily be that I have both smart people in one group and not so smart people in the other group, because just by chance, that might happen, okay? But with 5 people, that's going to be harder. If I have 50 people in each group, then that's probably not going to occur, okay? So the larger your samples, the better, okay? It kind of evens out that sampling error. And that's even what we talked about before, that larger samples will mean that you have less sampling error, okay? So that's the experimental study. If you want to show cause and effect relationship, you got to do an experimental study.